I'm very pleased to have a half hour to spend with Dr. Robert Denda from Enel, where we have a lot to talk about as it pertains to the distribution grid today, the distribution grid of the future, and importantly, an international perspective on that. So I want to start by first having you kind of walk us through Enel's footprint globally, and then what your role looks like within Enel's business.
Okay, perfect. Yeah. Hello, everybody. Enel is, as you probably know, a global utility. Let's say we are based in Italy. It's an Italian company, but with a global footprint. We are in 30 countries, and we basically operate the whole value chain of a utility. So we do from generation, T&D, retail, and renewables, also very strong. So we have, for example, if we look at our installed capacity, we have about 85 gigawatts installed and 37 roughly about in renewables. So we have a strong footprint in renewables. I'm in the business line of infrastructure and networks, so in the T&D side of the business. And there we are also one of the largest operators probably in the world. We serve 65 million distribution customers in our grids in 8 countries. We are the largest or the biggest distribution network operator in Italy, also in Spain, second largest in Romania in Europe. Then we are present in South America, in Argentina, Brazil, Chile, Colombia, and Peru. And also the grids that we operate are, of course, very different. In Latin America, we mainly operate city grids and the surroundings, so more an urban environment, especially the big cities like Santiago de Chile, Bogota, Lima, all of those, a part of Buenos Aires. So city grids. Whereas if we look in Italy, for example, we have about 50% of the customers. There, a big part is also suburban and rural customers. So it's a very different, let's say, footprint also in this sense. In total, just to give you some more data, we have about 2 million kilometers of lines that, I don't know, in miles, that is 1.3, something like this, no? A million miles of distribution lines that we operate, about 1 million secondary substations, just to give you some magnitudes that we have.
So you operate a diverse group of grids for a diverse set of customers. And so your role as the head of network technology and innovation, what does that entail within looking at all those grids?
Yeah, my role and the role of my team is to define, standardize, industrialize, develop the technology that we use within our grid businesses for all the countries where we are. What we really try to do is to find convergence, to converge to the same technologies, even though the grids are different. We try to apply the same technologies in the different countries, of course, achieving their big economical benefits as well due to the size. So whenever we do tendering or sourcing of any type of technology, of course, we have quite a big volume. And on the other side, of course, it helps us to also do the processes, do a process optimization to reach similar processes or the same processes in the countries where we are.
So can you give an example of what that actually looks like in practice? Like, what's a technology or a solution that you would identify, say, this is something we should be using across our various distribution businesses, and then how would it then spread across those businesses?
Yeah, sure. Like one example that is quite well known also together with Enel is smart metering, for example. We today operate over 41 million smart meters in our grids, and that was a project that was started in the early 2000s in Italy. We started and rolled out 32 million smart meters in Italy. That then in a second generation, we started to bring to other group companies. So we have over 9 million rolled out in Spain. We have a rollout ongoing in Romania, also some installations in South America. And there we always leverage on the same type of technology. And in fact, now we actually restart rolling out smart meters in a mass way in Italy, another 32 million, because it's already 16 years basically ago that the first generation of meters, of course, from a technological point of view, needs now to be changed.
So are you seeing an evolution in the use case for smart meters from the utility perspective? I think there was a first wave of rollouts, as you said, starting in 2000 through maybe even 2015 or something, where there was sort of an initial, here's why we should have smart meters. And I feel like that's been changing as DERs are growing and all these other things are happening. Now we're finding more opportunities to utilize smart meters.
Yeah, completely, you're right. At the very beginning, of course, there were different drivers, let's say market liberalization, so retailer switching, and these type of things, of course, also fraud prevention, revenue protection, those were, let's say, drivers for the first rollouts. But now, let's say, actually the meter, if we take the Italian case, now really has become a sensor in the grid that gives real-time information at the end point of the grid customer. So the actual part of measuring, let's say, energy data for the customer is of course relevant, but if you look at the electronics and of a smart meter, it's a very minor part. Most of the functions actually that bring a lot of benefit to the utility company as well and to the whole sector are related to other things, are related to process optimization, because right now we have basically real-time data, we have alerts, so for outage management, for optimization of the flows within the grid. You mentioned also the changes of the environment. Of course, we had in Italy, for example, 2011, 2012, there was a big boom of decentralized generation. We now, in our grids, have about 750,000 like small generators, and of course, to manage all of those points that in many occasions have during the day completely reverse flows. Of course, there again, a good understanding of also the low voltage side of the grid is necessary, and you get this information also from smart meters. On top of that, we also use other technologies. Together with the smart meters, we use, of course, remote control. We have in Italy alone almost 120,000 points in our grid that we control remotely and have also automized completely, so self-healing availability and functionality implemented. So it's in a completely autonomous way. And I think there was a presentation also this morning. It was mentioned also this aspect of smart switches. And this is exactly what we use. And now there again, we are also in a new generation where we actually bring down the time of the detection of a fault and recovery and reconfiguration, let's say kind of isolate the fault from the healthy section in less than 1 second. So that's really absolutely amazing, and is something that we start to roll out now again in Italy and will bring also to the other countries.
So that's a great example of technologies you are already rolling out. What's an example of something that you're seeing you haven't yet rolled out but that you're excited about?
Yeah, what we are really excited about is everything related to sensors, additional sensors in the grid. Of course, we measure all the electrical magnitudes already and the load flows and power flows. There we can do probably even more, but I think the exciting thing now is also, just some minutes before, I was also at this other conference that is right next door with the sensors. No? So bringing all those IoT sensors in your grid for so many use cases, you not only physical asset protection, we speak about predictive maintenance, bringing sensors in the grid that actually measure magnitudes, that measure acoustic variations, for example, of a transformer or vibrations of a transformer, have accelerometers on the poles, so whenever there's a variation there, together with other information, also from satellite, drones, 3D modeling, I think is another field that we are very excited about and what we really want to push also in the next future that we kind of have a physical model of the full grid and update this model with sensor information and with visual information for the inspection. So at the end, all of this brings a huge amount of data and a huge amount of value for the grid operation, because having all of that data, at the end, you can run cognitive computing, machine learning, AI on top of that and create a huge amount of value. We do this already in some fields, but not in all of the fields. Yeah.
Right. You're in Silicon Valley, so you had to get in a reference to machine learning and cognitive computing.
Course,
I think
yeah.
it's a rule. You know, I think your perspective is somewhat unique in that you're operating these distribution grids both in Europe and in South America, and the markets are structured very differently in those two regions. You've got unbundled sort of generation, T&D, retail in Europe, but it's mostly integrated, right, in South America. So can you talk a little bit about how regional differences impact decisions that you can make in the distribution grid?
Yeah, of course. No, if we look in the different grids that we have, just to give you an example, we have a catalog of all the components that we have in our grids, and it's 30,000 different types of components that are mainly due to different evolutions over the history of the creation of the different companies. And that is on the technical side. On top of that, of course, what you just mentioned is true. We have in Europe, we have a completely unbundled situation, so that we operate the distribution network operator, of course, are separated from retail business, whereas in Latin America, we are vertically integrated. So there, of course, what you can do is also very different. What we try to do, however, internally, when we apply the same technology to the different countries, to kind of do it in a virtual unbundled model in Latin America in order to map to the same model that we have in Europe. And this way, let's say, we define the boundaries that, of course, in some cases are within the same company in Latin America. And this is what we do in order to cope with this different scenario. Of course, what is true, however, that the opportunities are very different. And also, I think things that in the future can be done also will have a strong impact. If we think about storage, or like at the customer side, residential storage, for example, and EV, high penetration of EV, or at a certain point as a distribution network operator, you want to interact with those assets in order to optimize the overall grid. If we think about those type of scenarios, of course, let's say the boundaries between the different parts in a completely unbundled market become, let's say, the critical points, because you need to assure a real-time data flow, you need commercial information that flows, you need also technical information and control elements. And then also at the same time, there's the aspect of cybersecurity. Of course, that at the end, you need end-to-end cybersecurity, so that is another big aspect there.
Cybersecurity is an interesting one to talk about for just a minute. Is it, I think it was Ted Koppel, this famous news personality in the US who's since retired, recently wrote a book that is basically just terrifies everybody who reads it about the dangers of the cybersecurity dangers on the electricity grid specifically. Is that something that you worry about, or do you feel like actually the technologies you've got at hand to handle cybersecurity are sufficient?
Yeah, let's say I think it's never sufficient because it's an ongoing process. Cybersecurity for us is not a solution, it's a process, because at the end you need to continuously monitor what you have in your grid. We use aspects from security by design. At the beginning, when we define our solutions, we do continuously vulnerability assessments, we do different tests on our infrastructure, on our solutions that we implement, and of course have a strong team also in an organizational point of view that looks at all the aspects and monitors any type of attacks and reacts. So this is, I think, something that in my opinion is probably a big challenge, especially for smaller utilities, because it requires a lot of knowledge, a lot of specialized knowledge that you need to put in there. And of course, let's say being a utility of a certain size, it's probably easier because you have on one side, it's difficult because you have a variety of grids and so many components and so many points. But on the other side, of course, it allows you to build up the knowledge and have this in-house. And this is very, very important. If you just rely on third parties, you cannot manage. Yeah?
Great. There's some actually really good questions from the audience here, so I'm going to ask a few of them. Here's one. What, in your opinion, are the most compelling use cases for front-of-the-meter distribution grid data, apart from just unlocking internal efficiencies? How will you actually use that data? And do you ever think there's a point where third parties might pay to access that data?
Yeah, I think here we need to, sure, there are many aspects. Let's say there's, on one side, the information, of course, that is inside the meter, that at the end is the data that, in our opinion, belongs to the customer. And with the new generation meters, you have an interface when you can transmit that information to the customer. And then, but I think then, and this is a value, of course, for the customer itself. You can theoretically offer alerts, you can offer services based on that. So it's not, I think some years ago there was a lot of hype around, let's say, the usage of energy information in order to optimize, let's say, the actual demand within the customer home. I think, of course, that is there, and a certain percentage of optimization can be achieved. But I think there's much more to that. And for example, there's information that can be used in an automatic way by other devices, by home energy management solutions. And together, I think before, in some of the sessions, there was a discussion about the thermostats and so on. If you take all of these data together, this is when you create the value. And on the other side, I think there's also in the electricity side a value for anonymous data. And I think this is something that has not been explored yet. Let's see, really, if you use anonymized energy data in order to do a better profiling in order of customers, in order to detect problems maybe if you imagine a high-rise building, for example. Instead of looking at individual consumption, you can aggregate them, work with this and detect anomalies, for example, or secondary homes and with intrusion detection. I think there are so many things that theoretically can be done on the data that create a huge value for the customers and for the system. On the other side, of course, here it depends a lot, again, on the country, on the regulation, on privacy, of course, on data protection, on the actual market mechanism to enable this.
There's a few questions on blockchain technology,
Okay.
which there's actually been, I think, more conversation around this in Europe than there has in the US, though it's picking up a little bit here. Have you looked at opportunities for applications of blockchain on the distribution grid?
Yeah, for quite some years now, we look at the blockchain, and I need to say, to be honest, let's say we had this typical phase of excitement at the beginning, and right now we are at a phase, let's say, we say, okay, it's a technology, it's an alternative to many other things. Right now, we don't see it as a completely disruptive technology. I think it's a technological choice to do certain things. So it makes for sure sense for peer-to-peer operations. It makes sense to facilitate certain flows. It makes sense also where we see the value is that it creates transparency. So that, creating transparency also you create trust. And you can do this with blockchain. You can do this also in other ways. But their blockchain, of course, could be one of the options. So we look at blockchain. We not only in the business of infrastructure networks, so T&D, but also in other areas in order to facilitate data flows towards the customers and also new scenarios. But we believe there's a space for blockchain, probably not that one that we at the beginning believed for this when this hype started.
There are a few questions here that I'll sort of wrap together that are asking about high penetration renewable energy futures and sort of what does a, say, 100% penetration renewable energy future look like to Enel, or in the meantime, is gas a transitional fuel? From your perspective as the grid operator, how do you think about scenarios where you get really high penetration wind and solar?
Well, we already have, in fact, in Italy, and if we look at half of the peak is already renewable, basically. So that is with the 750,000 points that are managed. It is a challenge, but it can be managed through technology at the end, because either you reinforce your grids with huge investments, or you put in technology in there in order to optimize and control the power flows. And I think in this sense, with the experience that we have, that the penetration can, of course, go up. At a certain point, of course, you reach technical limits that then become another challenge to, let's say, to be managed, because at some points, no, of course, if you have complete reverse flows, you have islands, and so these type of things that, of course, need to be managed. But at the end, you need the right technology in place, so that's not something that we are scared of, and I think we already experienced quite a lot of that in Italy, especially.
I want to close out by talking about sort of the future vision for the grid. You're involved in this World Economic Forum group initiative called Grid Edge Transformation, which is supposed to be looking at the future of the grid. So paint us the picture. What does the grid look like in 2030?
Yeah, and I can recommend, by the way, the report that has been created by that group. You can find it on the World Economic Forum website, Future of Electricity, it's called. And in this working group, Grid Edge Transformation, we try to define, let's say, what does the future electricity system look like in 2030, roughly, you know? And of course, I think many of the things have been already mentioned here. Of course, let's say you have on one side distributed generation, electric vehicles, electrification basically of everything, transport. We think on the other side there's the digital domain. The customers are digital, the cities are digital, so the companies, the utilities, of course, become digital. So at the end, and it creates a whole platform at the end of exchange of energy in all different directions. On the other side, digital information, control information, but also information on the data flows. And then what we do in this group, let's say, not only we try to define that vision of 2030 roughly, but at the same time also we looked what are the main drivers in order to achieve that, and what are the main barriers. And there is a whole set of recommendations, high-level recommendations to regulators, needs also on the technology side, business aspects of different solutions that can be created. And with that, basically what we do within this project with the World Economic Forum, we go to different countries that maybe today are far away from that point, and kind of produce this leapfrog effect, so that we kind of say, okay, if you want to work today already in the direction of allowing, let's say, this future to happen, and it will come in any case, let's say, because the technology will drive it, why don't you directly create the regulatory framework, the let's say surroundings, the ecosystem, and so on, to facilitate that future vision. And this seems to have quite success. There are different countries now that are interested, and where different specific work has started to, let's say, kind of apply that scope to the country.
I think that future vision aligns pretty well with what we've been talking about at this conference, and sort of probably everybody in the room is largely on board with the idea. You mentioned, just as a sort of parting bit of wisdom from you, you mentioned that you look at where the biggest opportunities are and what the biggest barriers are. I guess I'd like to focus on the barriers side. If something is going to derail this transformation, what would it be? What do you think the biggest barrier is?
Yeah, I think it's not derail, let's say maybe hinder, because here, of course, we have always the regulatory aspect, because I think that makes a big change, because you need to have a certain flexibility in the market, so that at the end technology and the market kind of drive this. And at some points there's this chicken and egg problem, that investments are not made because the let's say the regulatory framework is maybe not there, On the other side, the regulatory framework is not there because the technology seems not to be there already because it's not installed. And I think this circle, let's say, to break this circle, you need to break it somewhere. No? And if you look at this, in many cases, it's we believe it's important to also help educate and help create conscience about this future vision, so that everybody that participates can collaborate. And at the end, it's the collaboration between regulators, of course, all the financial investments, the technology, and so on, all needs to come together. And that's maybe the barrier today, that still there's a lot of things going on in silos.
Great. Well, that's all the time that we've got this afternoon. As I mentioned before, we're headed straight from this into tracks. So everybody, as soon as we finish out here, just go out, make a right, and pick whichever track you'd like. But in the meantime, please join me in thanking Dr. Robert Denda.
Okay. Thank you.